Okay, I'm going to do a quick demo of both delay in simulation, delay on hardware, spinner in simulation, spinner on hardware. So first off, I'm going to edit the delay function. So currently I have it set up for doing the number of iterations in simulation. I'm going to go ahead and use the simulate task to go ahead and run this in the simulator. As before, it opens up a board view and the simulator. I'm going to go ahead and run through this old driver. And so it'll count 1 for 1 second, 2 for 2 seconds, and then 5 for 5 seconds. And then repeat. Okay, now that I know my code is okay, I'm going to go ahead and update it so it's appropriate for the hardware, and then I'm going to actually synthesize the RISC-V processor plus this code onto the hardware. So I'm going to go ahead and stop the simulation, and we'll update for the hardware. Okay, my code is updated to be appropriate for the hardware. If I tried to run it in the simulation now, it would be way, way, way too slow. It would seem like it wasn't working at all. Once I've got this code correctly structured, and in fact I can try and run this in the simulator, this at least checks my syntax to try and make sure that everything's okay, but I'm not going to bother to simulate it because it'll be crazy slow. So I'm going to go ahead and stop that. I'll even close the files that it opened up, and I'm going to use this task 3.3. This task will convert my delay.s file in the driver into machine code for me. So I'm going to go ahead and do that. It'll pop open the resulting machine code for me to look through. So it's got the machine code, the original instruction in my code, and these instructions at the top here represent the instructions that were in the driver functions. If I scroll down below, I will actually see the delay function. This is where it calls the delay function. If I scroll down further, I'll actually see what my delay code ended up turning into. The reason this is presented to us is so we can actually look through and try and make sure that all of these are valid instructions that our processor supports. Our processor should now support load up or immediate, and it already supported jump and link. And it should support add-I. It already did that, and store word and jump before we started working with it. So this is my chance to look through here and to make sure that I didn't use an assembly language instruction that turns into something that our limited processor doesn't support. I've already looked through this and it all looks okay. By the way, the problems tab will typically tell you if there are things that aren't supported, but it doesn't catch absolutely everything. We did our best to try and flag most of the things that commonly come up, but we can't guarantee it does everything. Okay, everything looks okay here to me, so I'm going to go ahead and hit the convert, the next one, RISC-V plus delay to bitstream. This is going to take that full processor, plus this, it'll put this in the ROM and it'll synthesize the full processor. This is going to take a fair amount longer than previous things we've done like this because it is a very complicated design. We can actually look at the terminal window and we can look at what it's doing as it's working through this, and it'll go through iterations and kind of show the overall process of converting it into a bit stream. So it's finally done. I am running this locally, so it'll be a little bit faster than it would be on a code space. I'm going to go ahead and switch over to my programmer. And I'm already connected to my Arduino. It's already uploaded it. So we'll take a look at it actually running on the hardware. So as you can see, it is running on the hardware. It is doing the exact same thing we saw in the simulator. 1 for 1 second, should be pretty precise now. 2 for 2 seconds, then 5 for 5 seconds. Okay, now I'm going to test out updates to my spinner code. So just like before, I've set my delay up so it'll work in the simulator. We'll try everything in simulation first. I am going to use the edit spinner task to edit my to paste in my spinner code, and I'm going to replace every place where there's an eCall with a call to eCall. Call to eCall proxy. And now that we're doing a function call, we actually have to make sure we're following the register conventions. So if we were using like T registers before, we may have to carefully scrutinize if calling this function will impact those T registers. And if so, we'll have to use the stack conventions and register conventions appropriately. Okay, so now that my spinner has been updated and my delay has been updated, I'm going to go ahead and use the simulate task and simulate this, and we'll see that the rightmost 7-segment display spins relatively slowly. It'll do 2 spins in the second segment over at a little bit faster rate, and then 3 spins at yet a faster rate, and finally 4 spins at an even faster rate. So it looks like this is all working okay in simulation. I'm going to go back and I'm going to update the delay function so it's appropriate for hardware, and we'll test this out on hardware just like we did with the delay. Okay, so I've updated my delay to be appropriate for the hardware. Now I'm going to go ahead and use the convert task to convert all of this code into machine language. And just like before, I can kind of review this and make sure it's only using valid instructions. I've already gone through that task. So now I can use the conversion task to take the RISC-V model and the spinner and convert them onto a hardware bit stream. Just like with the delay task, this is going to be a little bit longer than in previous examples this semester. This is a really, really complicated model. By the way, when I did this conversion task, I typically look at the problems tab just to make sure that there aren't any problems that were easily identified. So it's taking some time to do this conversion process. It's kind of showing the iterations it's going through as it's trying to map the overall Verilog design into trying to synthesize it so it'll work on the FPGA. Okay, it's almost done there. It's wrapped up. So if I go back to my programmer, it looks like my programmer is already in the process of uploading that update. And if I go over to my Arduino, I can see that it is actually running this code, and it's showing kind of this behavior on all 4 7-segment displays.